So let's discuss now how to name and differentiate acids and bases. Now take note for acid. The one definition of acid is when you put it in water, you form a hydrogen ion. You call this as hydrogen ion, and it will dissociate into an ion. Say for example, we have here hydrochloric acid. When you put it in water, so you write here an aqueous solution, it will form a hydrogen ion plus the anion. So this one is the anion. And also the definition of acid, if you can still remember, that is pH lower than 7. So meaning to say, the pH which is 1 to 6 will be considered as acid. And for the base, however, that is composed of cation metal plus hydroxide. So you call this part as hydroxide. So any base, when you put it in water, let's say for example here we're gonna have lithium hydroxide. You put it in water, so you put aqueous, therefore it will gonna have lithium positive plus OH negative. And if you could try to remember, the pH of base is from greater than 7, or rather we could have 7.1, 7.2, or better in whole number, that is 8 to 14. Now, one good characteristics in order for us to determine if a substance is an acid or base is when you use a litmus paper. So in testing acid and base, you always have to test or use blue litmus paper and red litmus paper. So here, if we're gonna have these sets of litmus paper, so for the acids, when you put these two litmus paper into an acidic solution, the red of course will remain red and the blue will become red. Now for the base, if you put these litmus papers in a basic solution, the blue will remain blue and the red will become blue. And this one, if you put a solution, say for example in water, if you put that litmus paper in water, say for example, then the blue will remain blue and the red will remain red. And that means that solution is neutral, wherein pH is equal to 7. Now, our focus for our discussion will be how to name binary acids as well as oxyacids and ternary acids. Now, let's focus first on naming binary acid. Examples of binary acids are hydrochloric, hydroiodic acid. We also have hydrofluoric. Now, as you can see here, once we say binary acid, we are referring only with two atoms or two elements. So the rule for binary acids are this. So number one, always put the word hydro and then end it with ick, and then say the word acid. So let's say, for example, we have here HI. So this one will be named as hydro iodic, and then there's the word acid. This one will be HCl, and then therefore this one, it means hydrochloric acid. Now take note, this is the word hydro, and then the ending would be ic. Now, how about, say for example, we're gonna name hydrosulfuric acid. Hydrosulfuric acid. Now, so write first the word hydro. So we're gonna have H positive, and then we're gonna use sulfide for the sulfuric, for the hydrosulfuric, and then therefore we're gonna have S, and we all know that the charge of sulfur is 2 negative. Therefore, the formula for hydrosulfuric acid would be H2S. Remember, we have to crisscross the charge. Now, how about if it is hydrobromic acid? If it is hydrobromic acid, again, we're gonna have here H positive. Sorry for this. So we're gonna have H positive, and then bromine will be negative, and then crisscross, this will become HBr. Okay, now that's how we name and write formulas for binary acids. Now, how about naming oxyacids or ternary acids? Now, from the word itself, oxyacids means these are coming from oxy anions. So here are the example of oxy anions. So SO4, 2 negative. This one is sulfate. While SO3, 2 negative. This one will gonna be sulfite. Now, if we were going to make it an acid, so put H positive, this is the hydrogen ion, and then this one is H positive as the hydrogen ion, and then we will gonna do the crisscross, so that will become H2SO4, and then this one is H2SO3. Now, the general rule for naming oxyacids are this. Number 1, do not use the word hydro. No hydro at the beginning. And then number 2, if the ion ends with 8, the acid counterpart, it will be ic, while if it ends in ite, the acid counterpart would be us. So here, as you can see, this one will be ending in 8. So the name of this acid is sulfuric acid. Take note, I don't use the word hydro. there is no word hydro here. And then this one would become sulfurous acid. Now, basically, this one ends in "ite." Therefore, if it will be an acid, that will gonna be ending in "ous." So, let's have another example. We have here the nitrate and the nitrite. So, say for example, this one would be the nitrate. And then this one will become nitrite. So if you're gonna have here H positive, and if we're gonna crisscross that, this will gonna be HNO3, and then this one will gonna be HNO2. Now kindly guess what will be the name of this acid. So if you name this as nitric acid, you are right, because there is 8. That will gonna be "ic" at the ending. And make sure no word hydro, because that one will be an oxyacids. And then this one will be nitrous acid. And that's it. That's how you name ternary acids. So again, if we have here binary acids, we're gonna use the word hydro plus the word "ic." And how will you determine a binary acid? There's no oxygen. While for the oxyacids, it will be coming from oxygen ions. Such a good example is sulfate, sulfite, nitrate, nitrite. And from 8, it will gonna be ending in "ic," and from "ite," it will be ending in "ous." Now this time, we have here the list of anions, and let's make it as an acid. So if we're gonna make this as an acid, this one is hydrochloric. This one crisscross the charge, and then this one crisscross the charge. Same with this, and then same with this. Now again, how to name this? Now if you try to look here, this one is a binary acid, so we will name this as hydrochloric acid. Remember, it's a binary acid. And then this one is hypochlorite. So expect that this "ite," it will gonna be turned in "ous," plus the word acid. So therefore, this one is hypochlorous acid. This one is in "ite." Again, it will gonna turn in "ous." So we're gonna have here chlorous acid. And then this one is in 8, and it will be replaced by "ic." So therefore, this one would be chloric acid. And then the 8 here, again, it will gonna be "ic." So therefore, the name of this is perchloric acid. So that's it. Now, how about naming in reverse? Say for example, we have here hydrophosphoric acid, and then we also have here the phosphorus acid, and then the other one would be phosphoric acid. Okay, now, how to name this hydrophosphoric acid, phosphorus acid, and phosphoric acid? Now, if it is phosphoric acid, take note that it will be coming from phosphate. right? And then from the phosphorus acid, that will be coming from phosphite. And from here, from the hydrophosphoric acid, that will be coming from phosphide, because of the word hydro. And this one will be coming from P3 negative. This one would be from PO3 3 negative, that is the phosphite, and the phosphate would be PO4 3 negative. So if we will make it as an acid, we're gonna crisscross it with H positive, and then therefore this will become H3P. This one will become H3PO3, and then this one will become H3PO4. So see the difference here? We have the phosphorus acid coming from the phosphite, phosphoric acid coming from the phosphate, and the hydrophosphoric acid coming from the phosphite. Take note that this one is a binary acid. Okay? Now for the base, it is quite easy, simply because we'll just have the same naming. I just want to emphasize that whenever you encounter a cation metal plus the OH, that is a base. Say for example, we have here Mg 2 positive, OH negative, so that would be MgOH2, and the name of that is magnesium hydroxide. And then we have here, say for example, we have Li positive, OH negative, and making it as a base, that would be lithium hydroxide. So it is just an ordinary naming. And if, say for example, we have this symbol AlOH3, that is named as aluminum hydroxide. Now, I just want to emphasize that the base is composed of a metal ion plus the hydroxide. That is the one definition of your base. Now, there are other definitions for acid and base, but right now, since we are just concerned with naming acids and bases in inorganic chemistry, therefore, this is the standard way of naming and the definition of acid. Now, what I want you to do is to pause and play the video as we answer this one by one. Ready? So what is the name of this? Can you try? So you may now pause the video. Okay. So this one will be named as hydrosulfuric acid. Why? Simply because this is a binary acid. This one will become hydroiodic acid. Now, how about this one? Kindly pause the video. Okay, so if you write here carbonic acid, that would be correct, because this one is carbonate. Okay, next, number 4. Pause the video. Okay, so again, this one will become, so this is coming from sulfate, and then therefore this one will be named as sulfuric acid. How about this one? And if you answer here, you have the phosphite. It will be coming from phosphite. This one is phosphorus acid, right? Because ITE, we're gonna end with us. Now, how about number 6? Perchloric acid. Now expect, what is perchloric? Perchloric is ClO4 negative, and then you make it as an acid, H positive. Therefore, this one is HClO4. How about for number 7? For number 7, that would be sulfurous. So it will be coming from SO3 2 negative, and then make it as an acid, H positive, and then that will become H2SO3. Now, how about for hydronitric acid? So there's a word hydro, and this one is nitric. So expect that would be N3 negative, that is a binary acid, which will be coming from nitride, and then make it as an acid, H positive. So therefore, this one is the hydronitric acid. And how about now for the nitric acid? Nitric acid, it will be coming from NO3 negative, that is nitrate, right? And then H positive, and then that would be HNO3. And how about this one, oxalic acid? Oxalic acid, it will be coming from oxalate. And what is oxalate? C2O4, 2 negative. It has a charge of 2 negative. Then make it as H positive. And then therefore, this will become H2C2O4. And that's it. That's how we name acids.